Hi, we're back again, and right now I'm with Richard Dracott of Intel. He's the head of HPC. I got that right? HPC.
I run the HPC business.
HPC business at Intel. So the big question is, and thing I'm interested in, is the Nehalem version for HPC that I read about just this morning.
That's right. So we have the Nehalem EX, which is the first time we're bringing the quick path interconnect and the large core count to the very high-end side of our processor line for the Xeons. It uses the same architecture as the Xeon 5500 series, which used to be codenamed the Nehalem EP, and it ranges anywhere from 8 cores is the maximum, but you have versions of the processor with fewer cores. Now this machine is really designed for systems with very large memory footprints, where you need a lot of memory bandwidth, a lot of I/O, as well as a lot of processing power. And the typical configurations, you can build 4-socket and 8-socket nodes, which gives you the kind of the fat node capability. And some of the system vendors you'll see are building machines that have a node controller that allow them to build an even bigger SMP configuration with even more memory hooked up to the processors. So that gives you, in fact, a 4-socket machine that could go up to literally a terabyte of memory, and an 8-socket that could go up to 2 terabytes of memory. So for those applications that really need a lot of memory, this is a really good solution. Now, the specific thing you're talking about is, we have within the processor something called turbo mode. So even when you buy the high-end product, you have the ability of trading off cores and frequency against power. In other words, if you have an application that doesn't scale well, you can actually disable some of the cores, and as that will run cooler, the part will know it can now speed up and stay within the thermal envelope. For kind of a frequency optimized SKU, if you will, which is really appropriate for the high performance compute world, we came up with a version which is just 6 cores, but has a frequency, it's about 20-30% higher than the normal top bin 8-core part. What that gives you is a part which from a CPU cost point of view is substantially less, but gives you a flops per socket which is comparable with the top bin part, and also gives you the same sort of memory and I/O capabilities. So we think that this is going to be very popular with some of the companies using these very large machines. Some good examples, people doing weather simulation, climate modeling, as well as oil well simulation would be another good example.
So, and this is really targeted at HPC, is that, as I understand it, this new version?
Yeah, the primary motivation for this particular version was high-performance computing. I'm sure that there will be other people who will figure out a way to use it, but that was indeed the genesis of the idea.
I'm just intrigued and happy to hear how HPC has become more and more of a bigger market than, big companies are actually saying it's a real market rather than a little niche over here that seems to use some of our technology. So it's...
No, I think the high-performance compute business as a whole has been growing very healthily. One reason is the broader commercial adoption over the last 10 years of high-performance computing solutions, whether it's into the financial world, oil and gas, or even doing things like crash test simulations and airflow, but on much more simple things like cell phones, or how do you stir paint in a can. I mean, there's really an amazing number of ways that high-performance computing is being used. So yeah, it's become already a very significant part of our server business. In addition to which, high-performance computing has always been at the leading edge, the fronting edge of technology adoption. And so on any given new technology we introduce, the Nehalem EP or the Xeon 5500 series was a very good example. Some of the fastest and earliest adopters are the high-performance compute industry. And they've been leaders in terms of adopting cluster technology, adopting Linux, as well as the different CPU technologies. So by working with the HPC community, we get a good understanding of where their needs are going. We can start to optimize our future products to meet those needs, and that actually gives us a jump in terms of what the broader commercial market needs, because the HPC world tends to be a leading indicator of where the broader market is going.
All right. So any other news from the show from Intel this year?
A number of things. We have announced that we're going to be beta testing our CT technology by the end of the year. This is technology that allows you to more readily parallelize your applications to take advantage of lots of cores and lots of threads. And as you'll hear, one of the recurring themes, even for the last few years, has been that one of the main ways of getting more performance is introducing additional threads and cores, but that requires the software developers, both ISVs and internal developers, to figure out how to take advantage of that parallelism. And I think a lot of the low-hanging fruit has been nibbled away at already. And now people are saying, okay, how do I go to the next step and take advantage of 8 cores or a dozen cores or whatever. The other big news, of course, was the top 500. We're very happy with how things worked on that. As you probably saw, we got 402 of the top 500. Yeah. That's a good number. 3 of those were in the top 10. I think the other interesting data there is that nearly all of the systems that were Intel-based are quad-core. And in fact, we have 20 Nehalem systems, or Nehalem-based machines. I beg your pardon. We have 20 of the Xeon 5500 series-based machines already in the top 100, and a full 20% of the overall list is already based on that processor. So that's barely 6-7 months after we started shipping the processor. We've already got 20% of the list using that.
Yeah, I noticed the uptake is really quick.
It's excellent.
Really quick. So
we're very happy.
And if it didn't work, it wouldn't be there. That's the real test. So
well, the processor architecture there really provided a huge jump in performance across a very wide range of applications. And while the top 500 is very good at in terms of tracking the Limpact performance, I think the real reason that people use this processor is because of its application performance. Applications that were previously bandwidth limited are now running as much as 2, 3, 4 times higher. I had a scientist at NASA telling me yesterday that on some of their systems they're seeing as much as a 6 times improvement in their code. And that's the same architectural construct, that the things that we did in the Xeon 5500 are the basis for exactly what we're doing in the Nehalem EX, which we're bringing out next year. And you can see a number of vendors on the floor who are already showing, early showing of their systems and what they can do.
Okay. Anything else?
I think you've covered the high points.
Yeah, that's what I was interested in, and I want to say keep up the good work, and we and I like what you're doing. So
excellent. Well, thank you very much.
We'll check in some other time.
Oh, I'm sure I'll see you at the next supercomputing.
Okay. Thanks.
Thank you.